Talk briefly about how the materials are also geometric representations of abstract comments or abstract concepts. So for instance, this is as Abby said, this is a material that they've been introduced to since they were in Children's House. But as we're starting to learn the basis of geometry, we can also reference it as a single point in geometry, or a line in geometry, a linear plane in geometry, and then also geometric solid. So again, very familiar materials to them, but now learned in a more abstract way. So it's building on concepts that they already have a firm grasp on, and attaching that abstract concept to a concrete realization which they already have. Another example of this is the trinomial cube. So again, something that they've interacted with since Children's House. But now in upper elementary, we can tie this algebraic equation to this concrete material. So it's again taking and again with the colors as well, something that they've seen since Children's House. So again, attaching a abstract concept, algebraic formulas, and cubing a trinomial to a concrete material that they already know. Another example of this is the decanomial. So using all of the bead bars, which they are familiar with, to lay out a table of squares. So multiplying the terms together with the squares coming in a diagonal pattern all the way up to 10, and laying out what is truly a really complex algebraic equation, but laying it out in geometric terms that have already been reinforced to them. So it's not so much telling them the algebraic equation as they understanding it and really discovering it for themselves and drawing on that abstract almost in that aha moment. And another specific example that I brought out here is this is a pegboard work. So using the pegboard to derive square roots. So here the child has been given the problem, the square root of 625, and they have laid it out. And they know that they need to start building the square of this square root. So they understand that they can only make 400 as the largest square that can go into 600. And then the largest squares from then on kind of follow this pattern. So now they know that they're going to derive 20, and then 20 again in the pattern of the square, and then fill in the rest with 25. And again, here is the self-correcting. There are no more beads in the bowls for them. If they were left over with 2 beads or 5 beads, that's a self-correcting nature of the material, just as Abby was talking about, in order for them to know that I need to go back and look at my work. And here again, using the material and recording it with pen and paper, we can allow them to work on this themselves and not teach them necessarily the tricks or the concepts that they might not understand if we just told them that. They can really come to these discoveries by themselves. And if you go one more, Leora, please. I mean, here's a problem that is incredibly complicated. The square root of 5,400,976, which by using the concrete materials that they've already been using since they were in Children's House in these reinforcements, I mean, they know that the answer is 2,324. Isn't this incredible?
We hope you come to Luku's teaching now to learn exactly how he's thinking that.
Luku's teaching now is a great opportunity to see this in action, all the way from the Children's House level all the way up.
So what level would they be?
This is upper elementary work. So this is currently, we're going through, and I'll talk about a little bit more about that in a second, but this is currently most of our 6th graders and a few 5th graders who are ready for it as well. And that's another concept of really meeting the child where they're at that I'm going to refer to here in a second. But great question.
So I kind of like for all of us to soak in all of these features of the materials that we just talked about. And I want to touch upon how all of these different characteristics help enhance the child's learning, and particularly how it pertains to their neurological development. Could you go to the discoveries?
Yeah.
I think we put on the. So each child is born with billions and billions of neurons, and their brain size itself can double or triple in size as they grow. It's not really the size of their brain or the number of neurons they have that impacts their learning. What really matters is the connection